I have a friend named Priska, a wonderful event planner. She organizes fabulous weddings and many more glamorous events. And guess what? She never disappoints. What has my friend Priska's event planning prowess got to do with probability? We will find out in this lesson. In this lesson, we will be looking at combined probabilities. We will be looking at how events happen and how they may be affected by other events. Remember that in probability, we study the chances of an event occurring. So, we have to know the relationship between events. We have what we call mutually exclusive events. These are events that cannot happen together. Like my friend cannot organize a wedding party and a funeral in the same hall at the same time. She can only organize a wedding in one hall and a funeral in another place. We can call these two events mutually exclusive events. But when we have two events that can happen together, then they are non-mutually exclusive events. My friend Priska once organized a birthday party and graduation ceremony for a lady in the same place not too long ago. This was because the lady's birthday and her graduation fell on the same date. Mutually exclusive events can be represented using this Venn diagram. We can see from the diagram that events A and B have no intersection. Therefore, they cannot occur together. Another example of a mutually exclusive event is that a pencil cannot be 2 cm long and 5 cm long at the same time. It is either 2 cm or 5 cm long. But a pencil can be both 5 cm long and yellow. These two events can be seen as non-mutually exclusive. This Venn diagram can be used to represent two events that are not mutually exclusive. We can see that there is an intersection between the two events, showing that they can happen together. Events can also be dependent or independent. What can an event depend on? An event in our study on probability is said to be dependent if its probability is affected by the outcome of a previous event. Like when a girl with a blindfold picks balls from a basket of many colored balls one after the other without replacing them. The probability of the second event of picking a ball is going to depend on the probability of the first because the number of balls in the basket has reduced. Independent events are events in which the outcome of the first event does not affect the probability of the next event. So, if the lady in our example picks a ball from the basket and replaces it, the probability of picking another ball with another color is not affected as it was in the case of dependent events. What about my friend Priska? She once encountered a client who tagged the probability of her hosting his wedding reception to the degree of satisfaction he receives from her organizing his father's 70th birthday party. Trust me, she wowed him. So, can you see another way an event can depend on another? Let's recap. We have learned that mutually exclusive events are those that cannot happen together, while non-mutually exclusive events are the opposite. We also know that dependent events are those whose probabilities depend on the results of a previous event, while independent events are the opposite. I hope you liked this. I will leave you to enjoy more.